Hello everyone, welcome to your second algebra unit. This unit will be on solving equations. Today we're going to start with solving two-step equations. Let's start with some vocabulary. What is the solution of an equation? Well, the solution of an equation is the value of a variable that makes the equation true. So it's going to be a number that makes the equation true. What is our goal when we're trying to solve equations? The goal is to isolate the variable to find the value that makes the equation true. And we do this by using inverse operations. So we need to know what our inverse operations are. Inverse operations are operations that undo each other. For example, addition and subtraction undo each other. If I start with 4 and I add 5 and then I subtract 5, I get back the 4 that I started with. So the subtraction undoes the addition. Addition undoes subtraction. Multiplication and division are also inverse operations. If I start with 10 and I multiply it by 2 to get 20, and then I divide 20 by 2, I'll get 10 because the division has undone the multiplication. There are going to be 3 steps to isolate the variable or get it alone. The first thing you want to do is locate or find the variable. Then, if there is any addition or subtraction in the equation, you're going to undo the addition or subtraction by using the inverse operation. Your third step will be to find the multiplication or division and undo the multiplication or division using the inverse operation. So the golden rule in solving equations is what you do to one side, you always must do to the other. I like to think of it in terms of having a little sister. If you have a little sister and your mom buys you something at the store and she doesn't buy something for your little sister, what's your little sister going to say? Probably something like, "Mommy, it's not fair." Well, equations are the same. If you do something to one side of the equal sign without doing the same operation on the other side of the equal sign, little sister might say, "Mommy, it's not fair." So always remember the solving equations golden rule. Whatever operation you do to one side of the equal sign, you must do to the other. So let's do some examples of solving two-step equations. So our first step is to find the variable in the problem. Here's our variable. In this problem we have an x. The second step is to find the addition or subtraction and do the inverse operation. So I have a plus 5 here. So I'm going to do the inverse operation, which is to subtract 5. And I'm going to follow the golden rule. I'm going to do the same thing on both sides of the equal sign. So on this side of the equal sign, positive 5 and negative 5 cancel each other out, and all we have remaining is 8x. Remember, positive 5 and negative 5 equals 0, and adding 0 to 8x isn't going to change its value, so we don't even need to write that 0. 61 minus 5 is 56. So now our new equation is 8x equals 56. Our third step is going to be to find the multiplication or division and do the inverse operation. 8x means 8 times x, so we need to do the inverse operation, which is to divide by 8. 8 divided by 8 is 1. So The 8 on the top and the 8 on the bottom cancel each other out. We don't need to write the 1 in front of the x because remember 1 times x is just the same as x. 56 divided by 8 is 7. So our answer is x equals 7. Pause the video and go over to the on your own column and do example 4. Okay, let's see how you did. So here's our variable. We now need to find the addition and do the inverse operation. So we're going to subtract 8 from both sides of the equation. That leaves us with 4y equals negative 20. You are combining two negatives right here. So a negative 12 plus a negative 8 is going to give you negative 20, or negative 12 minus 8 equals negative 20. They both mean the same thing. Now we need to do the inverse operation of multiplication. We'll divide both sides by 4. 4 divided by 4 is 1, so those cancel out, and we get y equals negative 5. Okay, let's go down to example 2. Here's our variable. This equation is set up a little bit differently than the other one because the constant comes before the term with the variable, but our steps are still the same. So we need to undo the addition or subtraction. Well, we have a negative 8 right here, so that's like subtracting 8. So the inverse operation would be to add 8 to both sides of the equation. Bring down the negative 10a. Okay. The minus sign in front of the 10a belongs with the 10a. It moves with it wherever it goes. 4 plus 8 is 12. Now we need to do the inverse operation of multiplication, which is division. So that gives us a equals 12 over negative 10. Can we reduce that fraction? Well, if we divide the numerator and denominator both by 2, that would give us 6 over 5. And instead of writing the negative sign on the bottom, I'm just going to put it in the middle. Pause the video and do example 5 on your own, and then check your answer. So the first thing you should have done is to add 4 to both sides of the equation. And that will give us negative 3x equals 0. Now we do the inverse operation of multiplication. So we divide both sides by negative 3. Notice when there's a negative number in front of the variable, you need to divide by a negative number. 0 divided by negative 3 is 0. So our answer is x equals 0. Okay, example 3. We need to do the inverse operation of addition. So we subtract 6 from both sides. This leaves us with m over 12 equals negative 9. Now we need to do the inverse operation of multiplication, or of division, which is multiplication. So now we are going to multiply both sides by 12. Let's make a fraction out of this one. So since we have a 12 in the numerator and a 12 in the denominator, those will cancel each other out, and it just leaves us with m over 1. If we divide m by 1, we still get m. So we don't need that 1 on the bottom. So we can just say m equals negative 84. All right, it's your turn on example 6. Pause the video, do the problem, and then we'll check it together. Example 6. Here's your variable. You now need to do the inverse operation of addition, which is subtraction. So we subtract 3 from both sides. Bring down the 2/5 x. Negative 9 minus 3 is negative 12. Now notice here we actually have two operations. We are multiplying by 2 and dividing by 5. So we have two inverse operations that we need to do. So the inverse operation of multiplying by 2 is dividing by 2, and the inverse of dividing by 5 is multiplying by 5. Now notice that the 5 in the numerator cancels with the 5 in the denominator and makes 1. The 2 in the numerator cancels with the 2 in the denominator and makes 1. So we get 1x equals negative, oops, it's not fair. You didn't multiply me by 5/2. Okay, now that we've made it fair and multiplied both sides by 5/2, let's do our multiplication. Negative 12 times 5 is negative 60. 1 times 2 is 2. So we have 1x equals negative 60/2. Let's simplify a little bit more. 1 times x is just x. Negative 60 divided by 2 is negative 30. So our answer would be negative 30. Okay, a couple of word problems and then we'll be done. It says the perimeter of the triangle is 81 units. Solve for x. We need to do two things. First, we need to write an equation, and then we need to solve the equation. Remember that perimeter is adding up all of the sides. So we can add 6x minus 4 plus 2x plus 4x plus 1. And then we're told that the perimeter is 81 units. So this means that our, 4x plus 1. That means that this is equal to 81 units. Let's simplify this equation a little bit by combining our like terms. So we have 6x plus 2x is 8x, plus 4x is 12x. And then we have negative 4 plus 1 would give us negative 3. So we have 12x minus 3 equals 81. So now this is a two-step equation that we know how to solve. First, we need to do the inverse of subtraction, which is addition. That gives us 12x equals 84. And we'll continue up here. Now we need to do the inverse operation of multiplication, which is division. And we get x equals 7. So our solution is x equals. Now for our second word problem, you sell your homemade cookies for $6 a dozen. This is with a 25% markup. So we're going to add 25% to the cost of making the cookies. That's what a markup is. How much did it cost you to make the cookies? First, let's define our variables. There's two things we don't know here. In the first sentence, we don't know how many dozen cookies we're going to make. In the last sentence, we don't know what the cost of making those cookies is going to be. So let's start to write our equation. So we have the cost of making the cookies, and then we are going to mark up that cost. So that means that we're going to add to it. And how much are we going to add to it? We're going to add 25%. So first we need to change that 25% to a decimal by moving the decimal point 2 places to the left. Now, are we going to mark up the price by 25 cents? No, it says that we're going to mark it up by 25%. So 25% of what? 25% of the cost of making the cookies. And then this is going to equal the amount of money that we make by selling the cookies. Well, how much do we make by selling the cookies? We make $6 for each dozen. So we make 6D. So let's simplify our equation a little bit. Notice that we have two like terms here that we can add together. So 1C plus 0.25C is 1.25C equals 6D. Then it asks us to give a solution to this problem, but we cannot give a solution unless we know how many dozen cookies we've sold. So we have some missing information. So I'm just going to say that we sold 4 dozen cookies. So that means that we're going to substitute the 4 for the D. Six times 4 is 24. Forgot to bring down my C. Okay, so now we need to solve for C. Remember, when we're solving an equation, the goal is to get the variable alone by doing inverse operations. Because this operation is multiplication, we need to do the inverse of that, which is dividing by 1.25. And 24 divided by 1.25 . 24 divided by 1.25 is going to give us 19.2. Now remember, this is dollars and cents, so that means that the cost of making the cookies is $19.20. So we'll put that over in our solution. So the cost of making the cookies is $19.20. Okay, make sure to bring your notes to class tomorrow.